All right, guys, we're going to pick up where we left off on Thursday, talking about graphs of exponential functions. As we move through the week, Friday is an e-learning day. You are going to have a quiz at home on Friday. Probably be one of the last large grades for the 9 weeks. Remember, the grading period is over on the 18th, which is not this Friday, but the following Friday. Okay, so you probably have this quiz and maybe one more. So just be on the lookout for that. And I'll remind you multiple times. I did. So the exponential function we talked about the other day. So there's a couple different ways we're going to write this. In the notes that I have written out for you is a perfectly fine way of writing it, like a to the x. Okay, and we go through here. It talks about the domain being all real numbers, basically meaning that you could put any number you want to in there for that x. Okay, but the output, the range, is only going to be numbers between 0 and infinity, meaning that the x-axis ends up being what we call an asymptote, a horizontal asymptote. We don't cross the x-axis. We talked about that on Thursday. There's a couple of points for every single function. So all exponentials of the form of a to the x will have the following 3 ordered pairs. They will have 0, 1. They will have 1, a. And they will have -1, 1 over a. In the equation y equals 0 will be an asymptote. Okay? So if I asked you to graph, for instance, let's say f of x equals 6 to the x. Okay? You're going to graph these 3 points. Okay? So you're going to graph 0, 1. Okay, what is my a value? If I look at that and compare it to that, what is a? A is 6. So I'm going to go 1, 6, and then I'll have -1, 1, 6. If you plot those 3 points, connect them with a smooth curve, and you will have your exponential. Okay, and I'll kind of demonstrate that here in Desmos for us. So 0, 1, 1, 6, -1, 1, 6. Okay. We'll also have the line y equals 0, like I said, as an asymptote. Okay, so we've got those points, and then all we would do is connect them with a smooth curve, knowing that as I get to the left of this black point, I'm going to get closer and closer to that y equals 0 line, or that red line, but I'll never touch it. So if I type in 6 to the x, does that go through those 3 points that we graphed? Okay. So like I said, every single time that we want to graph a exponential, we're going to come up with those ordered pairs: 0, 1, 1, 6, -1, 1, 6. Okay. Now, all of our notes here talk about the fact that y equals a to the x. Okay. But there can be a number out here in front that we can multiply by. So if I have like y equals, just to make it easy, 2 to the x, I can put a number out here like 3. Okay? Now, when I graph that, so let's look at what that number out front does. So I'm going to go y equals, I'm going to call that number out front b. It's going to ask me to make that b. You guys see as that b gets bigger and bigger, does it look like it's making that thing stretch vertically? Like it's getting pulled up, right? Does that make sense? Okay. But what's happening is that every one of these values on 2 to the x, if I graph 2 to the x, okay, every one of these points, these y values, gets multiplied right here by that 1 point. I'm going to make it a 3. Okay? So this point right here is usually 0, 1, right? Okay, that point on the black curve should be 0, 1. So let's plot that point. 0, 1. I should have 1 comma A, and I should have negative 1 comma 1 over A on that black curve. Does that make sense to everybody? Okay. If I take, because I have this 3 out in front now, okay, to get this green graph, I'm basically taking these y values and I'm multiplying by 3. What's 1 times 3? 3. So you see at that point right there, which was at 0, 1, now just went to 0, 3. Does that make sense? Okay. This point right here is at negative 1 comma 0.5, right? Well, if I multiply that by 3, see where it goes? Does it go onto the green curve? Okay. Multiply this point here, multiply its y value by 3. It goes right there. What's that y value right there? That's 6, right? Okay. So we can multiply by some coefficient out in front, and then that produces what we call a vertical stretch of our original function. Okay. Something that I want you guys to understand, though, because this is what a lot of people want to do. If I go y equals 3 times 2 to the x, something like that. What do you think a lot of people try to reduce that to or change that 3 to the 2x to? Y equals 6 to the x. Okay, can you see why maybe somebody would do that? Can we do that? Do they end up being the same graph? No. Okay, so these two things are different. Okay, and the reason they're different is because of our order of operations. If I look at that one that I have highlighted and I choose x to be 2, I have to take 2 squared first, right? And I get 2 squared is 4, and then I need to multiply that by 3, which is going to give me 12, right? So order of operations when x is 2 gives me 2 comma 12 there. If x is 2 in the red one, I get 6 squared. 6 squared is 36, right? So I have the order pair 2 comma 36. Those are completely different ordered pairs. So the order of operations tells us that I cannot rewrite 3 times 2 to the x as 6 to the x. That's a huge misunderstanding that we need to make sure that we do not do. Okay? So 3, you might want to write this down. 3 times 2 to the x does not equal 6 to the x. Okay? A generic way of writing that is like a times b to the x does not equal a b, the whole thing raised the x that way. But we're going to use those ordered pairs that we just came up with, 0, 1, 1 over 1 comma a, and negative 1 comma 1 over a, to take stuff from a graph, take an image from a graph, and create the equation that comes from it. Okay? You guys remember taking like, let's say I gave you something like this, and I say that the y-intercept is 2, and we go up 2. So from this information, if that's a y-intercept of 2, and it's a slope of up 2 over 3, so m is 2/3 and b is 2, you guys could write an equation that says y equals 2/3 x plus 2. Remember doing that? Okay. Grab information from a graph and put it into algebra. We can do the same thing with something like this. Okay. Now there's 2 points on here that we need to take. We're going to use this one, but we're also going to use this one down here, which is at 0, comma 1 right now. Okay. If they ever asked you to take a graph with 2 pieces of information on it and want you to find the equation of that graph, this is the route that you're going to go. You're going to write y equals b times a to the x. You're going to write that generic statement. Okay. Now, this is an x value. That's a y value. This is also an x value. And that is also a y value, right? Which one of those has got the easiest x value to deal with? 0, 1 would be the easiest x value, right? 0 is a nice number to work with. The reason we're going to grab this one first is because of what happens when we put 0 as an exponent. Okay? So we're just going to do substitution. We'll take this thing right here, and we're going to substitute that point. So we're saying y is 1, so I'm going to put this y to be 1. Okay? B, there's no b here, right? So we should leave b. A, there's no a here. We should leave a as a. But x is 0. And my hope is you see why we did that. What is a raised to the 0 the same as? 1. Anything raised to the 0 is 1, right? So I really have 1 equals b times 1, which is just b, right? Does that make sense, everybody? So now up in this original equation right here, I can replace b with 1. Does that make sense? Okay, so I'll start with this so basically we go through the entire process again, but now we have a little bit more information. B is 1. I don't know a yet. Okay, so once I find b, I just rewrite this with that value of b in there. Now, here's another ordered pair, right? Y is 25, so I'm going to replace this here with 25. Okay. A, so this 1, do I really have to write that 1 as I do this problem? It's just a coefficient 1 you don't need. So then A, and now X is going to be this number here. It's going to be 2. How would I solve for A now? Take square root, right? What's the square root of 25? So A is 5, right? Now, one last time, I now know what B is. I now know what A is. I'm going to put those back up into that original format. So let's write that here. Y equals B, we said was 1. A, we now just said was 5. And we'll raise it to the X. And then because it is a 1, I don't need to really write that 1 times 5. I just write 5 to the X. And 5 to the X will be the graph or the equation that is that graph. And we can check that once you have it developed. 5 to the X. Graph that. Is 0, 1 on that graph. And is 2, 25 also on that graph. Does that make sense to everybody? Okay, so I want you guys to take a brief moment. Got a different one here. Okay, we have 3 1/8, and we have 0, 1. See what you come up with for the equation of that by going through the exact same steps that we went through here. All right, so if we start with, we're going to start with y equals b times a to the x. Okay, what is the first y and x that you're going to plug in? You're going to always plug that first 0, 1 point in. Okay, so y is 1. B we don't know, A we don't know, but X is 0, right? So what's that tell me B is? Doesn't that thing right there turn into 1? So I have 1 times B, so B is 1, right? No. I think in the next one we see that. Then I'm going to go y equals B, which is 1, times A to the X. Does that make sense to everybody? Now, what are we going to use for X in this question? 3. And we use that for my Y, right? So we get 1/8 is equal to now, it'd be 1 times a, so I'm sure write it as a, and x is 3. Okay? Now, in the previous one, we took the square root to get a, right? What am I going to take here? Cube root. Okay? So it's going to be the cube root of 1/8 is equal to a. Okay, now here's my question, because that can simplify. What number can you multiply by itself 3 times to get 1? 1. So the cube root of 1 is 1. What number can you multiply by itself 3 times to get 8? 2. Okay, so this thing reduces to 1/2. 1/2 times 1/2 times 1/2 would give you 1/8. So now I've got a, right? So I go back up to the original problem. That right there. Y equals, b is now 1, a is now 1/2, and I'll raise that to the x. So y equals 1/2 x. We should be able to go into Desmos, type in 1/2 x, or 1/2 to the x. Gives me that. Is 0, 1 on there, and is 3, 1/8 also on there. And we see that it is, and that's the picture that they gave us, right? Does that make sense? Okay. I want you guys to take a moment and give this one a shot. Now, B will not be 1 in this one. Okay? But you still start with that point where x is 0. All right, so this one says so we go y equals b times a to the x, right? Okay, so we're going to start with this point again. Always start with the one that has the 0 in it. So y is 2, b times a to the 0, right? What's a to the 0? A to the 0 is 1. So does that tell you 2 is equal to b times 1? Okay. So then we're going to do it all over again. But now I know b is 2. Okay, now I want to use that point right there. Y is 6. 2 times a to the first, right? And it's a little bit different because it's a to the first. How do I solve for a here? Divide by 2. Good. So I get 3 is equal to a. Now I know a and I know b. I'm going to rewrite that original right there as y equals 2 times 3 to the x. Where are you putting 1? Right here? If you write 1x, is that what you're saying? No, you got to have the x. Is this something we can do? Okay, now, in light of our homework, there's not a whole lot of this. Actually, I don't think I have a single question of this on your homework, okay? I've got a lot of questions about this on your homework, okay? But this, what we're doing here, is going to get us to be able to eventually solve some equations. So we're trying to build some tools here at kind of a slower pace so that down the road we can solve some equations, solve some maybe story problems, and that's what we'll start tomorrow. So I'm going to stop today.